Okay guys, next we're going to be looking at reaction rates again and a little more getting into catalysts. So your reaction rate should increase with temperature. So as temperature is increasing, your kinetic energy is increasing, so your reaction rates, so they're all vary because there's more collisions, right? More movement, more velocity, because we know kinetic energy is 1/2 mv squared. Okay, next. We can still have collisions where your activation energy is less than the collision, as I said in the last video, but it may not overcome because your molecular orientation. So as I said, you remember how I said your activation energy this should be actually greater than. As I said, your activation energy has to be greater to overcome it, but it may not because the way the molecules are oriented does not allow them to bond. Okay. Now let's look at a little conjoining of the elementary steps and this activation energy idea. So here we have an energy curve, is what I call them. Well, we already can tell that this is an exothermic reaction because our products are lower on the potential energy scale. So next, there's 3 elementary steps here. 3. 1 is in this little trough, however you pronounce it. 1 is here and 1 is here. And then the rate determining step is sorry, I did not mean to say that. Hold on. Yes, I did. What am I saying? Yes, I did. Okay. Next. These are the 3 elementary steps. The rate determining step is right here. This is because it takes the longest. To overcome your activation energy. So I want to put that up there. It's also because it has the greatest activation energy, right? You see that? Okay. Yeah, 3 elementary steps or whatever. Catalyst. Okay. Catalyst will speed up a reaction, but to a certain point. To a certain point. Only past a certain point, adding you can add so many catalysts, but adding more reagents won't change the rate that it's being catalyzed at. So your rate will increase until all the active sites of catalyst are filled. It's independent of the concentration. If all the active sites of catalyst are filled, you're done. There's nothing more. Okay, so let's talk about homogeneous and heterogeneous catalysts. So heterogeneous catalysts are basically present in a different state when they are acting as a catalyst. So let's just say I have this is completely random, FeCl and H2. Let's say this is my catalyzing agent, this is a solid, and my H2 is my catalyzing agent. This is homogeneous because it's present in a different state. Heterogeneous. Homogeneous is present in the same phase. I think you get that idea. Yeah. Let's go to the next. This is homework, so I'm gonna sort of skip through this. Okay, here's catalysts. Okay, catalysts. So this is a representation on an energy curve on what catalysts do. You can see that obviously it's still taking the same amount of energy, it's just speeding up. Okay. Some reactions need to be sped up, but they can't always increase the temperature, safety, money, energy, everything. So they use enzymes. If you're good in biology, you know this, but this is not biology. Whatever. Catalysts work by lowering activation energies, and you can also observe this on the curve. This is the activation energy for the uncatalyzed, and you can see that it's significantly lower. And because of that, much larger fractions of collision are effective at a given temperature and rate and increase the rate. So heterogeneous adsorption of activation in regions, migration of absorbed regions onto surface, reaction, and they escape. So let's say we have this reaction right here. So NO is a true catalyst as it assists the production of O2 without actually being consumed. See, NO right here, producing O2, and then the NO2 will decompose into NO and O, and then this O will go bond with an O2 and create ozone. Sorry, not, I should have said production of O3. But eventually, in the overall, you notice that this is canceled out. So if they ask you to identify the catalyzing agent, it would be the one that is assisting a production, but it's not being consumed. The Freon example, I did a video on that. I went way more into depth if you want to look into that.